Standford, we have been interested in man-machine voice communication for over 4 years. Although the research is by no means complete, we would like to show you some results obtained as of autumn 1968. Our work is based on the analysis and classification of speech waves. Waves representing the changes in air pressure caused by our speech. This is a display of the waveform for the phrase, "Please come home." The top line shows the envelope of the entire wave, which has been divided into the following segments. T, L, E, Z, K, A, M, H, O, M. Analysis of such a wave poses many problems. Notice that it is impossible to say where one sound ends and another begins, or where one word ends and another begins. In normal speech, sounds and words flow into one another with no apparent boundaries. Thus, the phrase ice cream is ambiguous. So, for the time being, we restrict ourselves to the recognition of a limited set of isolated words or phrases, or a few simple constructs made out of these. For the purpose of analysis, we break down each utterance into quasi-linguistic units. Thus, the word faster is treated as consisting of a fricative, followed by a vowel, followed by a fricative, followed by a stop, followed by a vowel, followed by a consonant, followed by a stop. Another difficult problem is that the characteristics of an utterance depend not only on the words spoken, but also on the speaker, his environment, his emotional state, and his physical condition.
I love you.
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 Thus, we must ask that the speaker speak distinctly and not vary his intonation from trial to trial. This is an example of the analysis performed by the computer for the utterance 7. Parameters extracted from the speech wave are used to divide the utterance into segments with approximately similar characteristics. These primary segments are further subdivided if the within the segment variability is too high. Some of these segments are recombined, and we assign labels such as vowel, fricative, etc. to each of these segments. The sound description so generated is used to select the appropriate list of candidates from the lexicon. In this case, we choose all the two-syllable words which start with a fricative. Now we have to determine which one of these is most similar to the incoming utterance. Comparison with cycle yields a vowel similarity score of 88%, consonant similarity score of 49%, resulting in overall similarity score of 63%. The next candidate to be compared is 0, which is rejected as being very dissimilar. The candidate store is also rejected. A slightly different acoustic description of cycle yields a score of 70%. The candidate 7 receives a score of 93%. Another description of store is also rejected. On the basis of these scores, 7 is selected. We will illustrate the real-time operation of the program by means of 2 examples.
How are you? Comment allez-vous?
You can see that the message is recognized within a few seconds.
How number on cow?
This means that the computer does not know the message and is asking for help.
What is your name?
The written form of the message is associated with the spoken form, creating a new entry in the lexicon.
What is your name?
Pick up the big block at the right side.
This illustrates the operation of the hand-eye-ear program. The whole program takes about 75,000 words of code. It takes about 15 to 30 seconds from the time the command is given to the time the operation is completed.
Pick up every small block.
Unlike the previous example, where the utterances were recognized as a single unit, here the commands are analyzed by recognizing individual words within the sentence. For this, we require that the sentence should be not only syntactically unambiguous, but that it should be possible to determine word boundaries unambiguously, and that the words themselves are phonemically unambiguous. Before the computer can obey such commands, certain preliminary operations are required. The arm is calibrated. The transformation from the tabletop coordinates to the camera retinal coordinates is determined. The system is trained for individual voices.
Rescan.
Now the camera is instructed to look at the scene and generate descriptions of the objects in the scene.
Pick up the medium block at the bottom right corner.
The commands have to follow a predefined syntax and are usually of the form function followed by arguments. The segmental description and the amplitude are displayed. The operation to be performed is determined by comparing with the expected operation names. Having determined that the operation to be performed is pickup, the program scans the utterance for an object name such as block. The markers indicate the syllable being considered for a possible match with the word block. Now we look for qualifiers and quantifiers for the argument block. Now we scan for position arguments, if any. Recognizing corner, we then look for qualifiers such as right and bottom.
Pick up every block.
There are many problems that remain to be solved. Although individual hand-eye-ear programs work correctly over 90% of the time, the additive nature of the errors makes the combined program less reliable. If we wish to recognize several speakers reliably, at present we must train the system with all their voices. Language design for man-machine voice communication has proved to be